Yeah, thank you. Thank you, Prakash.
Thank you.
So, today's agenda is only one topic, which is ELB and auto-scaling group. Okay. So let me just share my screen. But before that, do you have any questions, please? Before I start with the session. Okay. ELB and auto-scaling group. Now let's say you have an EC2 instance. And you have an application on this EC2 instance. And usually we will not have only one server or one instance for an application, right? For high availability, we will have multiple servers, because what if the server goes down? So for high availability, usually there will be multiple instances. For example, I'm just taking here as 3 instances. Now the application will be deployed on these 3 instances. I mean, to say the same application will be deployed on these EC2 instances, right? Now, if you have 3 instances having the same application, these instances must be able to serve the request equally, right? Now, for that, we need a load balancer. Okay, so this load balancer will distribute the traffic to the EC2 instances which are in the target group. The load balancer will distribute the traffic to all the EC2 instances which are in the target group. Okay, so when you have multiple instances having the same application, one instance should not be overutilized and other one should not be underutilized. These instances must get equal request. For that, we need a load balancer. In AWS, we have an elastic load balancer. This elastic load balancer will balance the load which is coming from the internet by distributing to all the instances or the targets which are in the target group. It is called elastic because we can add the EC2 instance at any point of time and you can remove it. Okay. Now the load balancer, this elastic load balancer, not only distributes the traffic equally to all the instances, it will also check the health of the instances. Check the health of the targets or the instances. For some reason, if an EC2 instance is not healthy, the load balancer will stop sending traffic to that instance. It will be sending the traffic only to the healthy instances. Okay, now let's assume there are 3 servers. Each server is capable of 100 users. Let's assume. So there are 3 servers. There will be 300 users who would be accessing the application. Okay, now assume that there is an increase in the number of users suddenly. Now instead of 300, Now there are 500 users who is accessing this application. Suddenly there is a rise in the number of users. Now, because this is elastic load balancer and it's a managed component of AWS, whatever it may be the request, irrespective of the number of requests is coming to the load balancer, this load balancer will distribute the traffic to all the EC2 instances without knowing whether the instances will be able to handle it or not. So obviously, here we have 3 instances, but we have 500 users where these instances are capable of only 300 users. Okay, now when there is an increase in the number of users, what happens is the EC2 CPU will rise. The first thing which happens is the CPU rises because it's like, overwhelming the server by having more requests. Okay, so you're trying to access server more than its capacity. So what happens? The CPU rises. At some point of time, it reaches 90-95 and it will stop responding. Okay, now if the EC2 instance is not responding, the load balancer will make that instance as unhealthy. Okay, and it will stop sending traffic to that instance. Eventually, one by one, even these 2 instances will become unhealthy and the load balancer will stop sending traffic to any one of these EC2 instances where the user will face the page not found error. Okay, so even though we have the load balancer, even though its concept is to distribute the traffic to all the EC2 instances, if there is an increase in the number of users at sudden, the load balancer as usually will distribute the traffic without knowing whether the instances will be able to handle it or not. Okay, so that's where we have the auto-scaling group. Okay, so to avoid this kind of situation, what we can do is we can go and create an auto-scaling group, defining the policies in such a way that if the average CPU utilization of all the EC2 instances is greater than or equal to 80%, this number can be completely flexible. Okay, you want it as 60 or 70 or 90, it's completely up to you. Okay, so what you can do is if average CPU utilization of all the EC2 instances is greater than or equal to 80%, you can allow the auto scaling group to add an EC2 instance into the target group. Okay, and as soon as an EC2 instance is added by the auto scaling group in the target group, the load balancer will start sending traffic to this instance after checking the health of it. Okay, even after adding an instance, if the CPU is still touching 80, the auto scaling group will again add another EC2 instance. And the load balancer will start sending traffic to that instance as well after checking the health of it. Okay, so we can have an auto scaling group and add this target group under the auto scaling group, defining the policies so that whenever there is an increase in the number of users, the auto scaling group can add the instances to compensate the traffic coming from the internet. Now, let's assume there is an application already deployed and there is a new feature which is introduced for that application. Okay. Now, that feature is went live, means they have deployed with a new feature. It went live without testing properly. where a piece of a code in the new feature is going to an infinite loop. Okay, now when I say it's going to an infinite loop, that means a piece of code will be executing unlimited times. So when a piece of code is executing unlimited times, the compute power of that particular server will rise suddenly, because you're actually utilizing that compute power endlessly. So the first thing again, what happens is the CPU rises. Now, because the new feature is implemented in all the EC2 instances, all the instances CPU will rises, and within no time it will be touching 80. And auto scaling group, following this policy, it will add an instance. Even that instance will also have an application, and then the new feature that also will go for infinite loop, and then that again the CPU rises to 80%, and auto scaling group will add one more. So in simple terms, auto scaling group will go crazy and will start adding all the instances. I mean, yeah. And of course, in real time, no one will use T2 micro. Okay. So to avoid those kind of situations, what we can do is we can define a capacity. So I can just keep maximum number of instances auto scaling group can add. For example, in this example, I know that at a peak time, I will need 5 servers handling the users. So what I can do is I can define the maximum capacity as 5. Okay, or at least you can keep it as 6 in worst scenarios, but you cannot go for 10 or 15. Okay, so this maximum number of capacity can be given by monitoring your instances for a while. Okay, how many instances I need at max? Okay, now if you define this maximum as 5, auto scaling group will make sure that it never go beyond the maximum value. Okay, even if the CPU utilization of all the EC2 instances is touching 80 or greater than or equal to 80, auto scaling group will never go beyond the maximum capacity. Okay, now auto scaling group will not only add the EC2 instances whenever a CPU rises, it will also terminate the instances when the CPU reduces. Okay, when the CPU utilization is less, it will not only scale out, it will also scale in. Now assume that the number of users are actually decreasing. Okay, and auto scaling group will start terminating these instances, and then it is decreasing, and it will terminate that instance as well. So when the users are decreasing, the CPU utilization, the average CPU utilization will be very less, and auto scaling group will start terminating the instances eventually. Now let's assume there is only one user who is accessing this application, not 100. There is only one user who is accessing the application. If only one user accesses this application, the CPU of this instance will be still less, right? This instance is capable of only 100 users. Okay, but there is only one user who is accessing it. So because there is only one user who is accessing the application, the CPU of this instance will still be less only. Now, auto scaling group may end up terminating this instance also because the CPU is very less, where this user will face the downtime. This user is not able to access this application, and this application is not available. For example, if you open a Facebook at 2 a.m. or 3 a.m. in the morning, it will be still open for you, right? It will not ask you to come back at 8 or 9 a.m., right? That means the Facebook application is highly available. Whenever you access an application, if you are accessing it, that means that application is highly available. Okay, but in this case, the auto scaling group may terminate all the instances, even if there are less number of users who is accessing the application. To avoid this kind of situation, what we can do is we can define minimum capacity, where I can say it as, in this example, I can just say minimum as 1. Okay. So if I keep this min as 1, even if the CPU utilization of that particular instance, okay, is almost 10% or less than 10, doesn't matter. Auto scaling group will make sure that it has a minimum number of instances in the target group. Okay, so you can keep minimum as 2 or 3 or doesn't matter. Okay, so auto scaling group will make sure that it has the minimum number of instances in the target group all the time, irrespective of the CPU utilization. Okay, so if you are aware, if you know that, okay, at last you need a one server, where there is no much demand on the application. So what you can do is you can define a min as 1. And this auto scaling group will be in between the min and max following the policies. So it will start with 1, and according to the policy, it will keep on adding the instances and remove it, but it will never go beyond the maximum. It will never go below the minimum. One part of it. Now I said that auto scaling group will add the instances and terminate the instances. Terminating is fine, it just terminates. Now when auto scaling group is adding an instance, how auto scaling group know that that particular kind of instance to be added with this kind of configuration, the application also? So there is a component called launch template. Okay, launch template is basically a template which will have the instance configuration details. Okay, it will have the instance configuration details, where in this launch template, you will define the AMI, the instance type. Okay, so whether the AMI is having the application, maybe the AMI which has application, the instance type, the key pair, security group. So everything you will be defining in the launch template. From the launch template, you create an auto scaling group. Okay, so that whenever there is a need of adding an EC2 instance, auto scaling group will follow this template in order to add that kind of instance. And without a launch template, there is no auto scaling group. Okay. Now, when we say launch template, in launch template, we can create different versions. Maybe I have created a launch template. By default, it's a version 1. And I have used a T2 micro as an instance type, let's assume. Now later there is a requirement to change the instance type. What you can do is you can just define another version of the same launch template, maybe with a different instance type. And when you are in the auto scaling group, in the existing auto scaling group, you can edit and change the version, so that going forward, whatever the auto scaling group, whatever the instances which auto scaling group is adding, it will follow the latest version of that template. So we can have multiple versions of the launch template. Okay. Now, with the help of load balancer and auto scaling group, we can make the application highly available and fault tolerant. So with the help of ELB and auto scaling group, we can make our application highly available and fault tolerant. Okay, so when I say highly available, it will make sure that because we have defined the capacity correctly. See, this min and max has to be defined correctly, and it has to be monitored how many instances that need at max and min. Okay, so because we're having min and max and then managing the users, it will be highly available. And coming to the fault tolerance, even if there is a fault, this architecture will be tolerant enough. So basically, auto scaling group can heal itself. Now let's assume this EC2 instance became unhealthy for some reason. This EC2 instance is unhealthy. Okay. Now autoscaling group will just go and replace this instance with a new one. It will just terminate the existing one and it will replace with a new EC2 instance. So it can heal itself if there is a kind of a fault or if there is kind of an issue. Okay, because the autoscaling group is having a privilege to add an instance, autoscaling. Okay, so because it has a privilege to add an instance, it has a privilege to terminate the instance also. Okay, two scenarios. One is if an EC2 instance is unhealthy, autoscaling group will just go and terminate it and it will replace it. But you know what ELB will do? If an EC2 instance is unhealthy, the load balancer will just stop sending traffic to that. The load balancer cannot remove or add an instance. So it will just stop sending traffic to that instance. Yeah. Now, the last thing is, I said that whenever a CPU utilization of all the EC2 instances average is touching 80, autoscaling group will add an instance. Now, who will be telling to autoscaling group about the CPU utilization? CloudWatch. So with the help of ELB autoscaling group, silently CloudWatch, we can make our application highly available and fault tolerance. Okay, so CPU is a metric, right? We learned it yesterday. So CPU is a metric for the CloudWatch. So the CloudWatch will actually, when we create an auto-scaling group, we create that CloudWatch internally. Internally, it integrates with the auto-scaling group. So we don't explicitly go to CloudWatch and then create a room. Okay, so in the auto-scaling group itself, we will define the CPU utilization kind of a policy. Okay. So that's about the ELB and auto-scaling group. Any questions, please?
Madam, can you just iterate the use of versions? You said like for that launch template, version 1 and version 2 is created, right? So why do we need versions? Like it's just a configuration file, right? So if it is there using that configuration file, it will launch depending upon necessity. But why do we need versions? I didn't understand.
As I said, if you have, initially you used one version of the files, okay, where it has a set of configurations. For example, an instance type as T2 micro. Now later you want to go for a bigger one. So you cannot modify the existing one. So you create a new version and go for a new configuration.
Okay. So the old one is just, it's waste, it's dead, like it's.
If you don't want to use it, it's absolutely fine. You can create another launch template and you can use that as well. Not a problem. You can use only one launch template at a time, whether this. So when you're trying to use this, it will get deassociated.
Okay. Okay.
So if you don't want to use it, yes, you can get it launched and new one and then use this and delete it. It's up to you. But see, for auto scaling group, before we have two things. One is, two kind of templates. One is launch configuration, and the second one is launch template. Launch template is actually supporting different versions, whereas launch configuration is only one. Okay, you create a template and you use it. You create an auto scaling group from this launch configuration. And once you create a launch configuration, you cannot change it. So what you need to do is you have to create another one, and then you need to use this one for the existing auto scaling group. But in launch template, there's a privilege that where you can create different versions, and then you can use it any one of the version. Now AWS has removed this one. I don't know why. AWS says that we are not supporting this use launch template. So previously I used to use launch configuration only, but when it is it was told to use launch template, so I started explaining about launch template.
Thank
you. Understood? What happened, Santosh?
Yeah, madam, I understood. Thank you.
Any other questions? The concept is clear? Seriously? No questions? You guys are listening?
Yes.
Okay. Okay. If you don't have any questions, we'll try to implement this in the console. Okay. So what we will do, first of all, we'll create an EC2 instance manually. Okay. We will make sure that this instance is having a simple web server. Okay. And if you have a web server, we can access using a public IP address. Yeah. Now, the second step is creating a load balancer. So we'll create a load balancer with the target group. Okay. And we'll try to add this instance into the target group. As soon as an instance is added into the target group, the load balancer will start sending traffic to that instance, right? So first step is creating an EC2 instance and then manually and then having a web server and trying to access web server using a public IP address. The second step is creating a load balancer with the target group and adding this instance as a target in the target group. Okay, now we don't access this EC2 instance using public IP address. Instead, this load balancer will have a DNS name. We will access this load balancer using the DNS name from the browser. Now the load balancer will send the traffic to this instance only, and we will get the same output whatever we got when we accessed using public IP address. Okay. And the next step is creating a launch template, and then from there we will create an auto scaling group, defining policies and capacities. And for the demonstration, we will go the minimum value as 2, maximum as 5. Now, because I have kept the minimum as 2, auto scaling group will add 2 EC2 instances into the target group without checking the into the target group, and the load balancer will start sending traffic to these instances after checking the health of it. Okay. Now, once auto scaling group is added the EC2 instances, now if we check with the load balancer DNS name from the browser, it has to resolve to all the 3 EC2 instances one by one. So now what we're trying to prove is how auto scaling group is adding the instances and how load balancer is balancing the load coming from the internet by sending to all the EC2 instances one by one. Okay. So the first step is launching an instance and having a web server and accessing using public IP address. And the second step is creating a load balancer with the target group and adding this target into the target group. Third step is creating a launch template and creating an auto scaling group from this launch template, defining policies and the capacity. Okay. And the fourth step and the last step is accessing this load balancer from the browser. Okay. So we access the ELB DNS name. Understood? We'll implement this one by one. Yes. Hello. Any questions? Any questions, please, before I implement it? Okay. So now, the first step is creating an EC2 instance and having a web server. So let me just go to an EC2. Now go to instances and launch an instance. And name it as manual instance. For this demonstration, we'll go with Amazon Linux. Amazon Linux with under free tier. I'm going for the below version. Under free tier. T2 Micro 1. I will proceed without a keypad this time. In the default VPC, I just keep everything as it is. Now I don't need a keypad. So when I don't need a keypad, that means I'm not logging into it. When I'm not logging, I don't need SSH protocol. But I want to access this instance using public IP address from the browser. So I need HTTP protocol. Okay. And I'll stick with the root volume. But I also said that this instance will have a web server. So without connecting, I cannot see. I need to connect and install the web server, right? But instead, what I am doing is I'm using a user data. So if you remember, user data is basically a bash script where we can give some commands and launch an instance. Before our instance is ready, it will execute those commands. So what I'm doing is I'm automating the process of installing a web server by using user data. Okay, so it's a bash script. I'm updating my instance because I am using Amazon Linux. I'm using yum. If it is an Ubuntu, it would be apt-get. Okay, so I'm updating my instance. I'm installing Apache. So in Amazon Linux, we call it as HTTPD. Once I install, I'm starting that service. And I'm making sure that that service is on even if I reboot my instance. And I'm taking the public IP address of the instance, assigning to a variable. And I'm displaying that variable in the home page. Now, when I take the public IP address of the instance and when I access from the browser, I will not get the default Apache page or HTTP page. Instead, I will get this message, whatever it is in the quotations. So manual instance with IP. In this place, I will get the public IP address of the instance. Okay, so I can get the public IP address of the instance by running this command. So this is basically a generic IP address where anyone can use it. Okay, so it's a generic IP address to get the metadata of that instance. So from metadata, I am taking the public IP address and assigning to this variable. And I am displaying this variable in the home page. Like index.html is a home page. Okay, and I'm also creating another page which is health.html. And I'm just saying it as okay. So this health.html is for the load balancer. So I said that the load balancer will check the health of the instances, right? But what actually happens is we will create. So I'm just creating a health.html page in EC2 instance, and I will give this health.html path in the load balancer when I'm creating a load balancer with the target group. Okay. So now look to load balancer to check the health of the instance, it will hit that path. The load balancer will hit health.html. Okay. Now when it hit health.html, if the instance is running, if instance is working fine, it will give the response, right? So the load balancer, because it is responding, it will make it as healthy. If it is not responding, if the instance is not healthy, obviously it will not respond. So the load balancer will make that instance as unhealthy. Okay, so I'm creating this health.html for the load balancer. Okay, so I'm updating, I'm installing, I'm starting that service, I'm making sure that the service is on even if I reboot, and I am running a generic IP address to get the metadata. In fact, to get the public IP address from the metadata and assigning to a variable. And I'm displaying this variable in the home page. Okay, and I'm creating health.html for the load balancer. Okay, so with these options, I'm just creating and launching an instance. Okay, so now that we are done with the first step. Now let's move to the second step, creating a load balancer with the target group and adding this target into the target group. Okay. So let me just duplicate my tab and I'll scroll down and I'll go to the load balancers. Okay. And let me just go and create a load balancer. Now we have 4 load balancers. One is application load balancer, network, gateway, and the classic load balancer. So the classic load balancer is the previous generation one. It's the first load balancer of AWS. Okay. And AWS recommends not to use a classic load balancer because it's an older one. Yeah. But classic load balancer is still supported for the clients who are still using the classic load balancer. And AWS recommends to use application load balancer or network load balancer. And there is a new load balancer recently introduced, which is gateway load balancer. This gateway load balancer is explicitly used for third-party appliances. Okay, that support Geneva protocol. So this is explicitly designed for some sort of security compliance and policy controls. The way the gateway load balancer is different, and we are not discussing in detail about the gateway load balancer. Okay. Now, coming to the application load balancer, this application load balancer is used for applications where it supports HTTP and HTTPS protocols. And other protocols will be supported in the network load balancer, and Nest network load balancer is designed for speed. So if you wanted to send the traffic as soon as possible, where in a fast, a speed effective way, okay? So there you will use a network load balancer. But if you are looking for some sort of applications where you can access from the browser, then you would be using an application load balancer. Okay. Now our requirement is accessing the load balancer from the browser. Means HTTP or HTTPS. That means application load balancer is the correct load balancer for us. So I can just click on create. And you can also see how this load balancer works. Yeah. And I can just give a name, a load balancer. And I can also make an load balancer either internet facing or internal. If you want to access this load balancer from browser, from internet, you have to select internet facing. Otherwise, internal facing. Okay, so I want to access it from the browser, right? From internet. So I will just keep it as the default one, which is internet facing. And the IP address type is, I'll stick with IPv4. And I'm choosing a default VPC. And I am enabling all the availability zones. Okay. So, like this. Now, while I'm creating a load balancer, let's assume I have enabled 1A, 1B, 1C. Okay. But an instance in the target group under the load balancer is actually created in 1E or 1D, which is not enabled for the load balancer. Okay. Now, you can add an instance which is in 1D into the target group. But the load balancer, because it is not enabled, the load balancer will not send traffic to this instance, which is coming from the internet.
So there is no point of adding an instance into the target group, right? If it is not directing traffic. Okay. So that is the reason when you're selecting the availability zones, make sure that you add the availability zones of the instances which are in the target group. Okay. But for the demonstration, I'm just selecting all. Okay. I'm just adding, selecting all the availability zones under the VPC. Okay. Now coming to the security group. Now, see, you are accessing this load balancer from the browser. Now the load balancer security group must support the browser protocol. Okay. The browser protocol is HTTP or HTTPS. So because we don't go for HTTPS, we will go and enable the HTTP protocol. Okay. So this load balancer security group should have this protocol open so that you can access this load balancer from the browser. Okay. Now let's go and create a new security group for the load balancer. So I would say ELB security group. Okay. I will add HTTP protocol and then create it. Okay. Now you can just do a refresh and you can select the load balancer security group. Okay. And I can remove this default one. Now coming to the listeners, application load balancer supports HTTP and HTTPS, correct? So we will go with HTTP, it's a port 80. And the request will be forwarded to the target group, but we don't have any target groups. Let's go and create a target group. So first of all, the target type. So the target type is instances. Okay. You can have a target type as IP addresses, Lambda function, even another application load balancer under one. So there is a possibility it has a different use case. So we will choose our target is instances. We will select this and we'll just give a name as target group. And we'll go with the HTTP protocol, which is 80, a default VPC. Now coming to the health check. So here we will give the health.html path. Okay. And we can also go for advanced health checks. Okay. And when you're giving the health check path, make sure you give the correct spelling. Okay. So let's assume I have missed H. Now it will try to access this EC2 instance with the wrong name. So obviously that health.html missing H file is not there in EC2 instance. So even if the EC2 instance is running fine and healthy, because the load balancer is not able to access the instance because of the wrong spelling, the load balancer will mark that instance as unhealthy. Okay, so that is the reason you have to be very careful when you're giving a name for the health check. Okay, now coming to the health advanced health checkings. So I just discussed that AWS will AWS ELB will check the health of the EC2 instances. Correct. So internally, what happens is, so let's assume you have an EC2 instance and you have a load balancer. Okay, the load balancer will send a request and it expects a response. And sends a request and expects a response. If consecutively 5 times, if the load balancer is getting the response, then this load balancer will make that instance as healthy. Now, is 5 is a number, a mandate number? No. So default value is 5. You can go from 2 to 10. Okay, so you can have a 2 from 2 to 10. So if I keep 2, load balancer will expect a response, a continuous response consecutively for 2 times. If 2 times EC2 instance is responding for the request, the load balancer will make this instance as unhealthy. Okay. Now, if it is not responding at least twice, the load balancer will make it instance as unhealthy. But you can go from 2 to 10 again. Okay. So healthy threshold is if consecutively 5 times if it is responding, it will make us healthy. If it is not responding, it will make us unhealthy. Now, timeout is load balancer will make a request to the EC2 instance, and the load balancer will wait for 5 seconds to respond. Within that 5 seconds, if it responds, so it will mark under healthy. If it is not responding, it will mark under unhealthy. Okay, so timeout is the number of seconds that load balancer give to EC2 instance to respond. So you can go from 2 to 120. Okay. Now, to send the second request.
Ma'am, we couldn't hear you, ma'am.
Yeah, we lost you for a minute there.
Oh, okay. So am I audible now?
Yeah, madam. I think after timeout, we lost you.
Oh, okay, no problem. So timeout is basically load balancer will send a request and it will wait for the instance to respond. Okay, if you have made this timeout part. The load balancer make a request to EC2 instance and it will wait for this much of time to get a response. So within 5 seconds, within 5 seconds, the EC2 instance must respond. If it is responding, it will mark under healthy. If it is not responding, it will mark under unhealthy. Okay. Now, interval is, now let's assume that the ELB has sent a request and it responded. Now to send the second request, how much time it has to wait is the interval. 30 seconds. So how frequently the load balancer need to send a request to the EC2 instance? Okay. Success code is a default code, it's a 200. Now, if I have interval as 30 and a healthy threshold as 5, it will take almost 150 seconds to make an instance healthy. Okay. So it's too long for me. What I'll do is I'll change threshold as healthy threshold as 2, and I'll mark this interval as 6, so that within 12 seconds, the load balancer will make that instance as healthy or unhealthy. If it is not,
We lost you again.
instance as a target in the target group. Okay, so I'll select this instance and include as pending below. Yeah, and I'll create a target group. You lost me? Again?
Yes, sir.
Yes.
So what I have done, I just added this EC2 instance into the target group, okay? And I have created the target group. Okay. See, if I have some internet issue, I mean, this, at least this will throw an error, right? But I'm not sure. But anyways, so that's how I created a target group now. So what I will do, I'll just do a refresh and I will select the target group. Okay. Now there are some sort of add-on services. It's an optional one where you can add a global accelerator if you think it's required. Okay, I'm just keeping it this as it is. I'm not selecting it, okay, because it will cost us and it's not required for us now. And tax is optional, and you will see a summary of it. So here you can see all the options which you have selected, the name, security group, the availability zones you have enabled, the listeners, if you have any tags, add-on services, etc. And with these options, I'm creating a load balancer. Okay. So before this load balancer is ready, let me just go and go to the instance, select the instance, take the public IP address, and access it from the user. You see? So manual instance with IP, the public IP address of the instance. Okay, so if you access this instance with the public IP address, you will be getting this message. Okay. Now, let's go to the load balancer. And this is the DNS name which I'm talking about. So load balancer DNS name will look like this. The name of the load balancer which you have given, some ID, US list 1, ELB, AmazonAWS.com. Okay. Now, before I access it, I also wanted to show you the target group which it created with it. So I can select this target group. Here I can see the targets, okay, and there is a manual instance which I just added, and the health status is still initial. Okay, so we need to wait for this instance to be healthy, and then only I can access this load balancer DNS name from the browser, so that I get the output. So now the load balancer is still checking the health of the instance. So once it marks as healthy, I can access this load balancer from the browser. You are following me, right? I'm not lost there, right?
Yeah.
Okay.
But voice is changed.
Sorry?
Your voice is changed. That's it.
My voice got changed.
Yeah, I think. Bit low, I guess.
A bit low. Okay. So better?
Yeah, that's now better.
My voice is echoing. What happened here today? See, nothing got changed. My place, my room.
Now it's fine.
Okay, it's fine. Yeah. I haven't changed anything. Everything was exactly the same. Even me. Okay. Now, yeah, let's see that if the instance is healthy. Yeah, if you can see the instance is healthy now. Now, if I take the, did I paste it? Yeah. So if I take the load balancer DNS name and keep it in the browser, it should be resolving to only one instance because we have only one now. We have only one instance now. Okay. Now let's move to the third step quickly, and we will create a launch template first, and we'll create an auto scaling group from that launch template with the policies capacity, defining the min as 2, max as 5, and we'll wait for auto scaling group to add 2 instances into the target group. Okay. So let me duplicate my tab again. Go to launch templates.
create a launch template. And give a name. Okay. I'm just giving the same thing here also. And here I would select the AMI. Okay. So I'll go for quick start. I'll choose Amazon Linux AMI. AMI. Okay. And coming to the instance type, I would choose T2 micro. See, it's very much same as creating and launching an instance, right? Yes. So you look almost same, but not same, right? Okay. So I'm choosing an AMI. I have given a name to the template. I have chosen an AMI. I have chosen an instance type, and I will choose a key pair, some random key pair, and I can choose a subnet also, but I don't want to include in the launch template, so I'll just leave as it is. And I'll definitely create a security group. I would say launch template security group. Okay. And I will add a rule and I'll add HTTP protocol. Keep it as anywhere. So what I'm doing is whatever the configuration which the manual instance is having, the other instance also should have the same, right? So I am implementing that. I'm actually trying to create that configuration in the launch template so that autoscaling group, when autoscaling group adds that instance, it would be very much same as the manual instance only. I mean, in terms of the configuration. Okay. So for this EC2 instance, I have chosen Amazon Linux and T2 micro, and I'm choosing the same security group. When I say same in terms of the rules, I have open HTTP protocol for this. I'll also open HTTP protocol for other EC2 instance as well. Okay. So HTTP protocol. I'll stick with the root volumes and I'll go to advanced details. And here also, I will use the script. But this time, this is not a manual instance, right? I would say it's an auto-scaling instance. I'm just changing the name. Okay, so with this, I'm creating a template. Let's see if it is throwing an error. And view template. Okay, so I can select this template. I can go to actions and create an auto-scaling group. Okay, so now that we created a template, from that we'll create an auto-scaling group. So we are integrating slowly the ELB auto-scaling group, everything. So create an auto-scaling group. So here you can give a name, auto-scaling group as a name. The launch template is already selected with the default version. Okay, and I'm going to next. I select the default VPC. Okay, and I will choose all the availability zones. Okay, so the importance here is, let's assume you have enabled 1A, 1B, 1C for load balancer. For auto scaling group, you enabled 1D, 1E, 1F. Okay. Now, whenever a policy kicks in, the auto scaling group will add the EC2 instance in any one of the availability zone, maybe 1F. Okay, because the 1F is availability zone is not enabled for the load balancer, even if auto scaling group is adding an instance, the load balancer will not be able to send the traffic to that instance. There is no point of adding it. So when you are integrating the load balancer with the auto scaling group, you have to make sure that the same availability zones are enabled. So for ELB, I have enabled all availability zones, right? So for auto scaling group also, I'll do the same. I hope it's making sense. Okay.
I'm just choosing the same default launch template. And see, I am creating I have created load balancer target group in one step, and I'm creating auto scaling group separately. Now you need to add this target group under the auto scaling group, right? So you need to attach to an existing load balancer and select the target group. Okay. VPC lattice integration. No, we are not doing that. Okay. AWS has changed few things. Okay. So health check, I will make it as 10 just to reduce the time. And I'm not going for any additional options. I'm not enabling metrics also. I'm going to the next step. So here you can define the capacity, like I will keep the desired as 2. So desired is basically the number of instances you want to start with. Okay. So maybe you have minimum as 1 and max as 5, but I wanted to start whenever I launch an EC2 instance, I want to start with 2 instances. Yes, you can keep the desired as 2, but I will keep min and max as 2 only. Okay. So minimum instance I want to be 2 and the desired also I want to be 2. And here we have a policy. So you can just by default, the no policy is enabled. So I can just select the policy. You can give a name and average CPU utilization is 80, or you can change whatever you wanted. And you need not select CPU all the time. You have multiple options like network in and out, application load balancer, request count per target. Okay. So you can also create allow auto scaling group to add an EC2 instance based on other metrics also. Okay, not only the CPU utilization. An instance needs these seconds to warm up. So as soon as I launch an instance, let's assume I have launched this instance, right? As soon as I launch an instance, my instance will not be in running state. It will take few seconds at least. If I use T2 micro, it will take at least few seconds to get ready. Correct? Now, the same way here, it is asking when auto scaling group adds an instance, how many seconds it takes to get ready. Okay. So maybe if you're having a huge application, it will take some minutes. So you can just convert that into seconds and you can just enable here, or you can just give that number. For me, I think it's 10 seconds. So I'll just keep it as 10. Okay. And next thing is disable scaling to create only a scale out. See, we learned that auto scaling group will not only add the instances, it will also terminate the instances. So the CPU is less. But if you don't want the auto scaling group to terminate the instances, you can just enable this. So disable scaling to create only a scale out policy. Even this is also the same instance scaling protection. So if you enable any one of these, what happens is auto scaling group will not terminate the instances. But I'm not enabling either. I'm just going to the next step. And here you have a notification. So when I say notification, SNS will come into picture. So you can add a notification and you can select the topic. Okay. So that whenever an instance launches, terminates, fail to launch, fail to terminate, if you want to get a notification, yes, you can enable it. Okay. But I feel we have enough for now. So I'm not enabling, but if you're interested, you can try doing SNS. And I'm going to the tags, the last but one. So where I would give a name, auto scaling instance. Okay, so it will tag to the new instances. And I'm going to the next, where I can see all the options which I have chosen. So with these options, I will just go and create an auto scaling group. Okay. So it takes a while to create. And because we have kept the minimum as 2, the auto scaling group must add 2 instances into the target group. But first of all, let's see whether auto scaling group has launched 2 instances or not in the console. Okay, so now if you can just see, you have only 1 instance, right? But if I just do a refresh, you see, so they have Autoscaling group has added 2 instances that's just created. So you can just see the time. It's just now. Okay. So they launched 2 instances and they're still initializing. Okay. Now you can see these instances in the target group because you have added these instances in the target group. So you can make a refresh and check if, see. So 2 instances are added. Out of it, 1 instance is already healthy. Okay. So we'll wait for these EC2 instances all to make it healthy. And then we will take the load balancer DNS name. Okay. And we'll host it. But before that, I want to see the instances healthy. Yeah. Now that all the EC2 instances are healthy. Now, if I access, so the 4th step is if I access the load balancer from the browser, it has to resolve to all the 3 instances one by one. So now, first of all, it is showing auto scaling group instance, which ends with 203. If I refresh, manual instance 251. Auto scaling group instance 57. Auto scaling group instance 203. Manual instance. Auto scaling group 57. Auto scaling group 207. Manual. You see, the auto scaling, the load balancer is sending the traffic to all the instances one by one. It may not be 1, 2, 3, 4, 5, 6 kind of, but it will be round robin. It will be round robin, but you make sure that it is sending enough number of requests to all the instances. Okay. Understood? Any questions, please?
Madam, if you say scale out means it is reducing based on requirement. If you say scale in, it's increasing, right?
No, other way around. Scale out means adding.
Okay.
Scale in means removing.
Got it.
Understood? Any questions, please? Yes.
If the instances are unhealthy or if the time out response is very within the frequency it didn't respond, so it will terminate those instances and it will recreate the instance again immediately, or it will based on the
Venu, your voice is not at all clear. I haven't understood anything.
okay. Okay, I'll just ping that maybe.
No. See, please continue. So keep your microphone near you and then we can try talking.
Okay, how about now? It's clear?
Mm.
So only the thing is, if the instances are unhealthy, so means timeout is not responding within the time interval. So in that case, it will terminate those instances and again to recreate, or it will just terminate the instance.
Auto scaling group will terminate the instance and it will add a new one. If an instance is unhealthy, auto scaling group will replace it with a new one by terminating the existing one. Yeah, respond, yeah. If I answer a question, you should say yes, no, okay, understood something.
I said, I think you did. Yeah,
Okay, you said, okay,
hear
you
me?
unmuted and then,
Yeah.
okay, no problem. Mm. Oh, okay, I have a question. Yes, so maybe, so if I am having application manager instance, then should I need to deploy same app with the same configuration in both the auto scaling instance to use ELB auto scaling? See, I think Sachin asked different questions. Okay, see, you're missing the whole. See, simple thing. See,
The
the
reason why you use load balancer, because when you have a same application having multiple instances and you want to distribute traffic to all the instances. Okay, it is not that I need to use same application because load balancer need to send. No, you are using load balancer because there are multiple instances having the same application. Okay, and all the instances must receive the same number of requests equally. Okay, now coming to your next question. See, in real time, see, in this particular demo, I wanted to show you how to add an instance while creating a load balancer. I also wanted to show you how to integrate with load balancer with the auto scaling group. But in real time, this part will not be there. No one will manually add it straight away. They will create a load balancer, empty target group, and then auto scaling group. And the auto scaling group will start adding the instances based on the capacity we define. Okay, so but I also wanted to show you a few more options, so I added this one. Understood, Sachin? Yes.
Yes, ma'am.
Mm. Yeah.
So basically, like you said that they will directly create a load balancer with all the configuration, and auto scaling group will replicate that according to the um, traffic we have. Correct, ma'am?
Auto scaling group launch.
Yeah, launch. Okay.
Correct. Defined. I mean, according to the policies, auto scaling group will launch an instances. That's right.
Okay.
Yeah. Don't worry, guys. If you think whatever may be the question, please ask. Fine. Now, coming to the cleanup, when you are explicitly deleting the resources with the auto scaling group, first of all, you need to delete the auto scaling group before you terminate the instance. Now, if I terminate my instance before I delete the auto scaling group, what happens is, assume that I have terminated these instances. Now, auto scaling group, to maintain the minimum number of instances, it will immediately add 2 more instances. When I say immediately, of course, when auto scaling group finds that there are no instances, okay, then it will add 2 more instances to maintain the minimum. So when you are explicitly cleaning up, you need to first delete the auto scaling. So you wanted to see what happens if I terminate my instances first. So instead of deleting auto scaling group, first of all, I'll delete the instances. Okay, and I'll wait for some time. Auto scaling group slowly will add 2 instances. Okay, and also there is an incident happened in a company also, where they started using AWS, and they have the workloads in AWS in some testing phase. So because what they have done, they created EC2 instances, load balance, auto scaling group, everything. And due to a weekend, I mean, because that day is Friday, what they have done, instead of deleting the auto scaling group, they just terminated the instances and they left for the day, assuming that that cleanup is done. But by the time they come back in the morning, Monday morning, they could see that the instances are running. And obviously in real time, they don't use smaller instance type, right? So there's a huge building in the report. Okay. So in real time, yes, of course, you should be taking care of this auto scaling group because we are automating, right? So when you're automating something, make sure that you have kept the boundaries. Okay. So that it will not take its own decisions. Yeah. Now the instance are terminated. Oh, wow. Okay. So the instance are terminated. Let me just try to refresh and see if auto scaling group is adding an instance. You see? So an instance is adding, one instance is added, and also another one will be there. It will create, we'll wait. Okay.
So taking a while. Yeah. Yeah. So you see, auto scaling group has added another EC2 instance. Okay. So let me just delete the auto scaling group first. It takes a while. Okay, creating and deletion takes time, but I need not wait for that to delete the launch template. I can straight away delete it. Sometimes when you're deleting, it may throw an error. Okay, I'll tell you why. See, you are integrating, no? ELB with target group, Autoscaling group with launch template, and then Autoscaling group with target group. So you're integrating everything, all these components. Now, when you're deleting, if you find some sort of dependencies, it will throw an error. But not to worry, you can try after some time or try multiple times, it will delete. Okay. So now let me go to delete the load balancer and the target group. Okay, so it's cool. And you know what? The beauty is auto scaling group will terminate its instances. Now I'm not touching the instances. Now the auto scaling group is still deleting, right? So if you can see, it's still deleting, right? But you see, when I just refresh, the auto scaling group should terminate its instances. Yeah, you see. So when you delete the auto scaling group, it will delete all the components, including the instances which it created. So you need not worry about doing anything explicitly. Okay. Perfect. Any questions, please? Okay, so you'll do it now. So what we will do, looks like you don't have much questions and yeah. So usually there will be a lot of questions on this topic because I mean, maybe we have less participants. So what we will do is, first of all, we'll go for a break. Okay. And after the break, the rest of the time you can do it for a hands-on. Once you're done, you can just let me know and you can leave for today. Okay. And if you have any questions, of course, you can ask me. Understood? Yes. Shall we
Okay.
go for a break?
Yeah, sure.
Cool.
Madam, you'll be explaining the things. End of the session, you will be explaining about
Sorry, Ben, what is it end of the session?
tips. You will be explaining us about the tips of regarding the examinations, which we need to go through, what and all
Not
we need
tips.
to
Okay,
refer.
how to
Schedule it for the exam.
Yeah.
Have you got this Amazon shopping account?
No.
But yesterday I told that have a Amazon shopping account so that I can show you how to. Okay, I'll do one thing. I'll try to search for a YouTube video where you can study an exam. Okay, if you don't have an Amazon shopping account, that link will help you. Okay. Okay, Venu?
Yeah.
Yeah. Cool. So we'll go for a break and we'll come back. And then I'll create a breakout rooms for you guys can start doing on the hands-on. Yeah.
Anupama, today is the last day of the course, right?
Correct, Anil. That is the reason they have taken pictures. I mean, they can inform it before day so that you guys can be ready, but it was sudden notice. So yes, might be it is the last day of this course, but you have my WhatsApp number. You can just Message me at any point of time if you have any questions. Please don't call me suddenly because I might be in other sessions. So, for example, if I am in a session and someone calls me, I cannot. I mean, if I talk, it will be not good, right? So the same way. So you can have my WhatsApp and you can just WhatsApp me if you have any questions, but please don't call me. And if there is a need of call, we will schedule it and then we can discuss on the same. Okay. Most of the things I'll try to solve it in the chat itself. But if I think there is a need of a call, then we will have a call. Okay. So at any point of time, even if it haven't taken like after few months also, so don't worry, just send me a message that okay, if you have any questions related to your career or if you need any suggestion regarding AWS or any skill. See, very simple. If I'm aware of it, definitely I'll help you. Otherwise, I'll try to help find some sort of resources and I'll try to help you. Okay, so this course is done, but my support is still will be there. Okay. Yeah. So let me share my screen. You guys can go for a break. Happy break, guys.
Hi, is everyone back? Okay. So I'm just creating 3 breakout rooms. Please do join and complete this lab. So once it is done, please let me know that you're done and then show me the output and then you are good to leave. Okay. So you can refer the lab, the project to ELB and Autoscaling group in the drive link. There you will find the script. Okay. So the script and the steps which you are supposed to do. Yeah. So please do join into your rooms and let me know if you have any questions, call for help if you're stuck somewhere. Okay.
Hi, Ganesh, you have any question? Can you please join the room?
Sachin, share your screen. You can unmute and ask, okay? Sometimes I may miss your messages. So share your screen and show me what is it.
Looks like the user data which you have given is wrong. So go to that. Why you have two instances? Select one. First of all, unmute yourself. I can't hear you, Sachin. Sachin, I can't hear you. Oh my God. Is there any problem with my thing? No. Fine. So go to the instances. That's fine. So let me try to fix it if possible. Terminate one instance which is not. Now take the public IP address and show me it in the browser. Drag your cursor, drag your window down so that it will not mess with exactly. Perfect. Correct. So now open a new tab. No. Open a new tab. Close this. Close this. Yeah. Enter. So manual instance with IP. So when you are trying to get the public IP address of the instance, it is throwing an error. Okay. Now go to actions. Instance settings. Scroll down completely, edit user data. Third one, fourth one from last. Scroll down. So fundamentally, there is a mistake somewhere here. That is the reason it is throwing an error. So check now if you have exactly copied the same thing. It is not able to get the public IP address from that. So have you enabled anything else apart from it when you are launching an instance, Sachin? Go to the browser. Go to the Zoom. Go to the Zoom, which you just went before. Down you have left side down. You have microphone. Can you please click on left side? I said. Can you talk?
Hello, no ma'am.
Perfect.
Enable.
Yes, I can hear you now.
I just copied the assessment from this one. Okay. Just
yeah.
copy.
But if that is the case, why it is saying not authorized. So you might have enabled something else which you are connecting from two devices, Sachin?
Yes, ma'am. Right now.
So from in one device, keep your speaker off so that you will not get that echo.
I just.
Okay, no problem. Ignore it. So cancel it. Cancel. So while you are creating an instance, if you have enabled, whoa. Not that cancel. Okay, cancel. Down in the console. Down. In the middle. Cancel. Close this. Go to instances. So while you are creating an instance, have you enabled anything else?
No, I just using Amazon, like, let me show you
Linux.
what, yeah, Amazon Linux and T2 Micro, no key pair, and in network settings, I
No,
allow.
Scroll down completely in advanced settings. Have you enabled anything?
No, I allow HTTP traffic.
No. Scroll down completely in advanced settings. Advanced details. Scroll down completely.
And I paste
Have you
it.
enabled anything else above?
No.
Then it should be fine, Sachin. Try one more time, no? So cancel it. So terminate that instance also. So is this the second time you're getting the same?
Yeah, second time.
Why it is saying unauthorized? Are you creating a default VPC or a custom VPC?
Default VPC.
Default VPC.
Okay. Do one thing, Sachin. Whatever the script which you're copying, copy it. Don't keep it in the console directly. Keep it in text. What is it? A text document. Okay. And then copy from there to in your instance. Okay. For the last time, try to create another instance. Okay. So open a text document and try to exactly paste there. Whoa. Yeah. Now copy there and then paste it in the console. Now first terminate the instance. Do one thing. So I'll just stop sharing. Terminate the existing instance which is there and launch an instance. Make sure you're taking care of all the details. Okay. And if it is not working, then you may need to give control to me. I'll take care. Okay. And please connect to Zoom from your laptop and making sure that you have a Zoom application installed. Okay. If you connect from browser, I can't take the control. So if I can't take the control, I can't help you definitely for sure. I cannot give each and every instruction, right? It will take a lot of time.
But
it creates a lot of chaos. Okay. So try to install Zoom and then connect from there.
Ma'am, I have Zoom installed in my laptop, but I already connected with that, but I am in breakout room in that. So how do I?
Now you are not in breakout room. You are in the main session.
No, ma'am, I think I am in breakout room. Santosh?
So how you're talking to me?
Yeah, madam, he created another session while talking to you. He created one from the browser and contacting because the one through Zoom he is connected to the breakout room. So we created another session just to reach out to you.
Oh my God. Okay, that way. That is the reason. Okay, I can see your screen from one side.
Yeah,
That is the reason I'm seeing duplicates.
Same issue. I tried disabling SSH and enabling HTTP. So I'm facing the same.
Santosh, you're also having the same issue?
Yeah, same issue, madam. I don't understand what I enabled.
Okay, so both of you guys, okay, one second. Both of you come to the main session. Leave the breakout room.
Okay, ma'am.
Okay.
Yeah. I'll help you.
चलो भाई.
ब्रेकआउट रूम से ब्रेक मिल गया.
चलो अभी माँ काम करेंगे.
पर सही.
Recording.
Hello, ma'am.
No.
भाई दो बार आवाज आ रही है.
Yeah, Santosh. Please share your screen.
Okay, ma'am. I'm sharing my screen.
Give me the control. Let me see what's happening.
What if I'm choosing first one in the Amazon Linux, like so?
I understood that you are doing that. So that's for different use case, okay? Can you please paste that user data? I think you're doing the same thing. Both of
Yeah, madam. Both issued the same one.
Now it should be fine.
What's different with this one?
So you can read that, okay? When you're launching an instance, you can see what exactly is that.
Okay.
So it is explicitly saying that it is preferred for something else. Okay, it was recently introduced. Okay, so this is the general one which we already have, which is Fleeter. It is saying
Okay.
UEFI preferred. So maybe it will hide some sort of details and it is throwing an error, unauthorized. Okay.
Okay, ma'am.
Good. Yeah. Okay. You guys are not selecting this. See? Got it. Okay.
Okay, ma'am.
Please go back to your main breakout room and then continue doing whatever you're doing.
Breakout rooms.
How do we go? Okay, breakout room. Got it.
Okay, ma'am. Thank you.
Mm-hmm. What happened, Santosh? Can you hear me?
Hello?
Yeah. Santosh, can you hear me?
Hello.
Ma'am,
What happened?
ma'am, we have done this. Let me show you.
Okay, refresh. So I'm in another room. So maybe you have joined few minutes back. Oh, wow. Okay, perfect. You can go for cleanup. First, delete the auto scaling group and then load balancer and then the instances. Okay.
Okay, ma'am.
And once you're done, you're good to
Hello?
go. So check if you have done everything. Okay.
Okay, ma'am.
Yeah, Santosh, what happened? You're calling and then you're not talking. Okay, Santosh, you're done. Fine. Please do the cleanup. Okay. Okay, Santosh.
Yes,
Cool.
मैडम को दिखा दिया
Yeah, Santosh, you're done.
hello
Santosh, can you hear me? Can you hear me, Santosh? I can see your output.
Hello.
Santosh, if you're done, please do the cleanup and you can leave for today. Okay.
Yeah, madam. I just completed. I wanted to
I've
retry
seen your
again.
output also. Yes. I've seen your
Thank you,
output.
madam.
Okay. Yeah.
Okay, madam.
Hi, is everyone done? Have you completed doing the hands-on? Yes. Everyone? Shall I close the call then? Can someone respond, please? That you are done? Yes, no, maybe.
No, ma'am.
You haven't completed? You said yes, sir.
No, ma'am.
Okay, so where you are stuck, Ganesh? What is the progress? Can you please share your screen and show me where you are stuck?
A little bit server issue.
Okay, so you can do it whenever your internet is up. Okay, so what about others? Okay, let me just close the call. Thank you guys. Bye-bye.